Good evening, friends. Study with Apal Engineering and General Geology Parvin Singh book. तो चैप्टर 10 में द स्टडी ऑफ मिनरल्स फॉर्म के बारे में पढ़ रहे हैं. फॉर्म फॉलोइंग फॉर्म्स आर मेट विद इन द क्रिस्टल्स ऑफ द टेट्रागोनल सिस्टम. बेसल पिनाकोइड 001. An open forms with two similar faces and each face is parallel to the two-head horizontal crystallographic axis and meet the thirds and vertical axis at unit length. This in figure. Prism. These are open forms of four or eight faces in which each face is essentially parallel to the vertical crystallographic axis depending on their relations with the other two axes, and three types of prism are recognized in the tetragonal system. Prism of first orders 1, 1, 0, 4. Four faces, each face meet the two horizontal axes at unit length and being parallel to the vertical axis. And prism for second orders and 1, 0, 0, 4 faces, each face intercept only one of the horizontal axis and is parallel to the second axis, besides being parallel to the vertical axis. Okay, so prism of third orders of or ditetragonals and prism HKO. Eight faces, each face intercepting the two horizontal axes at different length. 210 310 pyramids. These are closed forms of eight or six faces in which each face essentially is meet the vertical crystallographic axis. Three types of pyramids are recognized on the basis of their relationships with other crystallographic axes. Pyramid of first order HHL, eight faces. Each face cuts the two horizontal axes at equal length besides intersecting the vertical axis. Example 2 2 1 and 2 2 3 1 1. Pyramids of second orders HOL. Eight faces, each face cut only one of the two horizontal axes. It is parallel with one horizontal crystallographic axis. Example 201 101. And pyramids of third orders HKL, also called ditetragonals. A pyramid is a closed forms of 16 faces in which each face cuts also the three crystallographic axes at unequal length. Example 3 to 1, 4 to 1. Other classes and of the remaining six classes, the following three are well represented amongst minerals. Tri-pyramidal class, pyramidal hemimorphic classes, and sphenoidal class. Examples of tetragonal minerals and zircons, visovenite, rutiles, and Vernerite and the cassiterite, octahedrite and chalcopyrite, scheelite and wulfenite and bronite. Hexagonal system. Definition: all those crystals which can be referred to four crystallographic axes, of which three axes are horizontal, equals, interchangeables, and intersecting each other at 120 degree between the positive end. The fourth axis is vertical and at right angles to the three horizontal axes are grouped under hexagonal system. The exiles diagrams, the horizontal axis all being equals are designated by the letter A, A1, A2, A3, and the vertical axis by the letter C as a usual. Divisions. The hexagonal system consists of two distinct divisions, namely the hexagonal division and the rhombohedron trigonal division. The first includes seven crystal class and the second five crystals class. The two divisions will be described individually. The hexagonal division: symmetry of normal class, axis of symmetry 7 in all and one axis, verticals of a six-fold symmetry and six axis, and horizontal of two-fold symmetry and plane of symmetry 7 in all, one plane horizontals containing six axes of symmetry and six plane verticals and vertical diagonals and a center of symmetry form. Form of hexagonal systems differ in characters from the forms of all the other system in that their parameters, indices, and symbols are determined with respect to four crystallographic axes and not the three as in other system. and thus the relations of any hexagonal forms is expressed by the general terms HKIL. It may further be pointed out here that H plus K plus I is equal to 0 is a typical relations true for also the forms belonging to the hexagonal system. B0001 and opens forms of two faces in which each face meet the vertical axis only. A prism, as defined earlier, is an open form in which each face is essentially parallel to the vertical axis. Following the three types of prism are met with in the hexagonal system. Prism of first order 1 0 overhead 1 0. An open forms of six faces in which each face is parallel to one of the three horizontals axis beside the vertical axis. It cut the two horizontal axes at the unit length. Prism of a second orders 1 1 2 zeros and open forms of axis faces like a prism of first order, but in this case each face cut all the three horizontal axes, two axes at equals length and to the thirds at greater length. It is of course parallel to the vertical axis. Prism of third order and HKIOS, it is also called a dihexagonal prism, as it has doubled the number of faces 12 and compared to the six faces of prism of first order. In this forms and each face cut all three horizontal axes at unequal length. Pyramids are defined earlier. A pyramid is a form that essentially intercepts the vertical axis. Like prism and three types of pyramids occurs in hexagonal system. Pyramids of first orders and 1 0 1 1. It is a closed forms of 12 faces, 6 above and 6 below the horizontal planes. Each face essentially is cutting the vertical axis and two of the three horizontal axis. It is parallel to the third horizontal axis. Pyramid of second orders HH to HL. It is also a closed forms of 12 face, but in this each face cut all the three horizontal axes and two of them at a unit length and the third at double the length. It also cut the vertical axis. Pyramid of third order HKIL. It is also called a dihexagonal pyramid as it has doubles the numbers of faces 24 of an ordinary hexagonal pyramids. Each face is a dihexagonal pyramid cut all the four crystallographic axes at unequal length. Rhombohedral divisions and symmetry. The normal class of rhombohedral division has the following system. Axis of symmetry: 4 in all, one vertical axis of threefold symmetry and three horizontal axes of twofold symmetry. Plane of symmetry: 3 in all the planes are verticals, diagonals in position, a center of symmetry. Form: rhombohedrons. The most common form of this group is a rhombohedron, a solid bounded by six similar faces, each like a rhomb, and meet the vertical axis of the three horizontal crystallographic axes. Each face of rhombohedrons meet the two axes and is parallel to the third. Or the rhombohedrons has a symbol of 1 0 1 1. The usual method to hold rhombohedrons is a steady position in along its vertical axis, C axis, which join the two trihedral angles, also called the pole angle. So in such a positions, the three horizontal axes join the middle points of the other sides. The rhombohedrons is further distinguished into an obtuse type or an acute type, so depending upon the values of the poles angles, which is the turn depends on the axial ratio A ratio C. As a general rules, greater the length of the C axis with respect to the A axis, more acute is the rhombohedron. So in this figure, rhombohedrons obtuse, acute, angle शो किए गए हैं, positive and negative rhombohedron. So rhombohedrons are also distinguished into positive and negative types, and when is in a steady position as describes above, so the rhombohedrons present a full face to the observer. It is taken to be a positive type when hours and age is in front of the observers. In the study's position, it is designated as a negative rhombohedrons, and the two types together make a complete